is no longer thinking about this. Oh, shoot, I'm doing exactly what I didn't want to do. Am I? No, it's okay. It's okay. So, quickly, somebody, am I solving for the naive or the sophisticate? The sophisticate. I meant to start with the naive. It doesn't matter. Okay, so the point is, so we're doing the sophisticate. So the sophisticated self 2 foresees that her Sunday self, self 2. Yeah, self 2 is not engaged in prediction because self 3 doesn't have a choice. Self 1 foresees that self 2 will choose to watch the Saturday movie, so they cross Sunday out of their choice set. Okay, they cut that branch off the tree, and now self 1 is comparing the undiscounted value of going immediately, which is 24/16, to the discounted value of going waiting a day and going to a better movie, which is 18. And so self 1 also chooses to watch the movie right away, right? Which means that any equilibrium that involves that outcome is now unviable. Okay, so in some sense you could say, we talk about credible threats and credible promises. So if self 2 was to say to self 1, you know what? Don't go to the movie on Friday. If you don't go to the movie on Friday, I promise I won't go on Saturday, and we'll both get the value of the Sunday movie. What backwards induction does is it shows you that's not a credible promise. The Saturday self won't follow through. If you're sophisticated, which is to say if you have perfect information about the other players, then you're going to know that that's an empty promise, that's a non-credible promise, and so you're going to say, no, I'm not even willing to consider 3. And then self 0 now knows that 1 will watch, which means that self 0 is not going to consider watching on Saturday either, and so self 0 is choosing between the discounted value of going on Friday night and the undiscounted value of going on Thursday night, and just sits down and watches the movie on Thursday night, crying over the missed Johnny Depp movie, knowing that knowing that her preferred option is out of her reach. Would much prefer to go see Johnny Depp, right? Johnny Depp would give her 27/16, and the Thursday movie is giving her only 16, but she knows she won't hold out. There was Andrew. That is not surprising. I was confused when I started doing this stuff, too. That's not good, because it means you're no smarter than me, and that's bad news.
Like, is 36 over 16 still better than 24 over 16? So when they say, well, I'm taking tomorrow, but they'll still feel better than...
Oh, no, so the 36 is self 2's payoff for going to the movie on Saturday. Self 1 is looking at their payoff, right? So self 1 is comparing this, the discounted payoff from going to the Saturday movie, to this, which is the undiscounted payoff from going to the Friday movie.
So they're basing paving on how they feel about paving today, that's how paving will feel.
Tomorrow. Bingo. Okay, so where I want to get to is actually investigating some of the lessons that we learned from this, but first I want to spend a moment making sure that you have a basic handle on how to do this. The first step is to draw the tree, which is to say represent the sequence of choices that this person has to make in their different periods. Okay? I spent a long time, I got this wrong because I put don't watch on these branches and watch on that branch, and it took me a long time to realize that that was a boneheaded mistake, and the game really didn't work at all. So first you draw the tree representing the choices. The next trick is to write out the payoffs. Now the payoffs are the actual utility function for each player. Right? So I talked about this last time. It's really important to distinguish between each player's preferences and their beliefs about their future self's preferences. So self 1's preferences are how they feel about the movie in period 0, plus beta times how they feel about beta times how they feel about the movie in period 1, plus beta times how they feel about the movie in period 2, right? So that, you use this utility function to fill in all of self 0's payoffs, here, exactly as you would with a table of utilities. That's how player 1 in time 0 makes her choices, based on those payoffs. But first she has to evaluate what she believes the other players in the future will do, and she evaluates that based on her beliefs about their future payoffs. Okay, so first you go through and you plug in, right, so the next thing you want to know is what is the person 1's, I'm doing the same thing. These subscripts are time periods, right? So self 1's payoffs, right? Now period 0 is out of the picture, and it looks like that. Okay? And that's what goes into these places. Again, what we're doing here is we're figuring out the payoff function, the utility, the decision-making process for each individual. Then to do backwards induction, what we have to do is at each stage of the process, we have to think to ourselves, if I'm self 0, I'm trying to decide whether or not to watch the movie, I got to go and analyze what I think self 2 will do and what I think self 1 will do. That's based on what I believe their utility function will be. Okay? So player 0 then has to evaluate her future self's choices based on this little DeLapper that you may remember, her beliefs about her future preferences. So we could say, what is her belief at time 0 about her preferences at time 1, right? And it's going to be that she thinks this player is going to choose on the basis of U1 plus beta hat U2 plus beta hat U3. And then you get to look at it and say, okay, well, what's beta hat? If it's a sophisticate, beta hat is beta, which is to say that she thinks that her future selves are going to be making decisions on the basis of what their utility function actually is. She knows her future self's utility functions. If beta hat is 1, this is a naive, then you've got to reconsider what they think their future self will do. They're going to blow it because they fail to predict what their future self will do because they have incorrect beliefs about their future self's utility function. Okay? All right. Having said all of that, let's do this. Did you guys just completely thrash this in your handout so you're not going to be able to use it for another round of the game? Okay, well, lucky you because I repeated it a page ahead. So making use of this, right, so here's what I did wrong, right? First I said we were going to solve for the naive, but we didn't. We solved for the sophisticate. So here I said we're now going to solve for the sophisticate, but we're not. You're going to use this one to solve for the naive. And the clicker question is, when will the naive student go to the movie? Figure it out. Alone or with your neighbors? Okay, why don't you take another 5, 4, 3, 2, 1 seconds to put in an answer. All right, so what did we get? Aha! So some of you, a lot of you thought she would go right away at t equals 0, and some of you thought she would wait till Saturday, and slightly more of you thought she would wait until Sunday. Let's just, for the sake of time, let's just actually work through this together, shall we? Yes, thank you. A little call and response is always a nice thing. Okay. So the key here is to understand what the naive thinks is true about her future selves. Yeah, I usually do this somewhat weirdly reverse sexist thing where I always refer to the sophisticated as she and the naive as he. And that's partly to reflect a somewhat silly stereotype about men being goofier than women. But it's also because I have this penchant for calling the sophisticated Sophie and the naive Nigel. So we have Sophie the sophisticated and Nigel the naive. So, and we're not doing sophisticated, we're doing the naive. We're doing Nigel, fine. So the point is that Nigel always thinks that his future selves will be making their choices on the basis of undiscounted utilities, or rather that that they won't be discounting the future by beta. So the naive thinks that these are always going to be the utilities that his future self will be using. Okay? Which is another way of saying that the naive thinks that his future selves will be time-consistent delta exponential discounters, no beta involved. Right? If beta is equal to 1, we're back to the discounted utility Samuelson model. Now, what's the key feature of the Samuelson model? If people are exponential discounters, what is the most salient feature of their decisions that we will observe? Time consistency. Okay? So now you can save yourself a whole lot of game theory by simply knowing that, so if your future selves are time consistent, that means they're going to stick with the plan. Right? The whole point of a time-consistent individual is that they stick with the plan. So the naive thinks, hey, whatever my favorite plan is right now, my future selves will follow through on it because they'll be time-consistent. So you can now take advantage of that insight and save yourself a whole bunch of time because you can just go forwards. You don't have to go backwards now. What does self-zero prefer? Well, self-zero is comparing 16 to 12 to 18 to 27. Of course, self-zero wants to go on Sunday, so self-zero will not watch. That kicks the decision forward to self-1. Self-1 thinks, right, so self-zero wants to go Sunday and assumes that his future selves will also follow through. Gets to self-1, whoa, what a surprise is this? Now I'm discounting, even though I predicted I wouldn't be. I'm comparing 24 to 18 to 27. But I make the same, now I say, well, actually, I do want to follow through because even when I discount the Johnny Depp movie, it's still better for me. So it's starting to look like this person is doing a pretty good job until we get to Saturday, and self-2 is now evaluating 36 sixteenths versus 27 sixteenths, and suddenly doesn't follow through on the plan, okay? And decides to welch out on the deal and watch the movie on Saturday, okay? So the trick you want to harness is, or the insight you want to harness, is that if beta is equal to 1, the person is time consistent. If beta hat is equal to 1, what it means is that the current self believes their future selves will be time consistent. Then you just take advantage of what time consistent means, which is it means you'll follow through on the plan. So in each time period, the person chooses their favorite outcome and marches forward confidently assuming that their future selves will follow through. Now you might ask yourself, why would you still believe that on Saturday? Right? Well, the real question is, why would you still believe that after going through several film festivals? There's a really interesting question in all of this, which is, why doesn't experience overcome naivete? It does in some cases, it doesn't in others. I actually haven't had a piece of sugar sweetened cake in a really long time. Okay, does everybody get that? Everybody get the way we do this? We go forward to the naive because we take advantage of their belief that their future selves are time consistent. But they're never going to get to period 3. I didn't write down any payoffs for person 3 because they don't have a choice to make. If it gets to Sunday, they're going to have to go. So I didn't worry about them. Yeah. Okay. I don't think I have time for this. Okay, let me just read the question. Well, why don't just everybody press a letter? We're not going to look at them. I just want you to get your participation points. I don't have time to do the discussion post-clicker, but let me just ask the question. Why does the sophisticate always do the task sooner than the naive? Right? So we saw the surprising result. The problem set, she did it sooner. The movie, she did it sooner. Okay, so why? Is it because she can commit to doing the unpleasant task sooner but can't commit to doing the pleasant task later? Right, she can commit to doing the problem set sooner by just doing it. She can't commit to doing the movie later because that's a decision that's up to her later self. Is it because she knows the outcomes she wants aren't actually possible, which is another way? Is it because she correctly foresees that certain things aren't an option? Right? She does the problem set early because she knows that doing it on Saturday when she really wants to isn't possible. She goes to the movie on Thursday because she knows that Sunday and Saturday are both out of the question. So because she foresees the limitations on her true choice set, she foresees the branches of the game tree that are going to be cut off, right? She always does it sooner. Or is it because her sophistication makes her more impatient? No, it doesn't. We know that. So either A or B. So these are different answers. They're not the same. B, they're not the same, but they're closely related and they're both true. Okay, everybody clicked? Fine. All right. So now let's wrap up. And you should read the paper. This paper is a Matt Rabin spectacular in the following sense. The math is genius. The guy is going to get a Nobel Prize for certain. Whether he's still alive when he gets it is anybody's bet. But no, he will be. The math is brilliant. But you don't need to understand the math in order to get the insights because the writing is also brilliant. And so he has written up, he and Ted O'Donohue, who interestingly is at Cornell, have written this in such a way that you can really understand the basic insights just by reading their explanation of the simple movie and problem set examples. Okay? So here's the summary. There are two generalizable effects in the situation where you're doing it once and you're trying to decide when to do it. Okay? The first effect is the present bias effect. Present bias causes procrastination when costs are immediate, and what they call pre-properation, which means doing it too soon, when rewards are immediate. Okay? Problem set, nasty thing immediately, you want to procrastinate it. Present bias will cause you to procrastinate. Rewards are immediate. This is a tempting thing. You'll do it too soon because present bias makes you tempted and want to do it right now. And this is going to be true for naives and sophisticates, both. Okay? Now, it might be, there may be situations in which present bias doesn't actually change their behavior, but it's always going to make them want to do it sooner. It's always going to make them want to do it sooner. Okay? For both naives and sophisticates. So when the costs are immediate, both of them are going to want to do it later, and when the rewards are immediate, both of them are going to want to do it sooner. Then there's the second effect, which is the sophistication effect, and this is where things get interesting, which is that the sophisticate always does it sooner than the naive in either situation. Okay? She procrastinates more because she is correctly pessimistic about her future misbehavior. Okay? She does it early to protect against future procrastination. Okay? She pre-properates, that's supposed to be more, isn't it? She pre-properates more She does it even sooner when it's tempting. Why? Because, again, she's correctly pessimistic about her future behavior, so she does it early because she can't control her future pre-preparation. I know I'll be tempted in the future, so what the heck? I might as well do it now, because all of those yummy things out in the future are actually not going to be possible. Okay. So here's the general principle. And I don't think this is in the paper. This is a very categorical generalization of these results. If future misbehavior, so future procrastination or future pre-preparation, raises the cost of current misbehavior, then sophistication will mitigate the effect of short-run impatience, right? In the case of procrastination, being sophisticated makes you do it sooner, which is good. So sophistication helps in the case of procrastination. Why is that? It's because future misbehavior raises the cost of current misbehavior. Because I will procrastinate in the future again, procrastinating now is going to hurt more than a lot, right? So my future, the Saturday self procrastinating till Sunday, makes the consequences of procrastinating today bigger. Right? So in that case, sophistication helps you and mitigates the procrastination. If your future misbehavior will lower the cost of current misbehavior, then sophistication exacerbates the effect of short-term impatience. So in the case of the movie, pre-properating, going to the movie too soon on Saturday night means, and then again on Thursday night, means that the cost of going on Friday night means that the cost of pre-properating on Thursday isn't as great, because you're not going to miss the Johnny Depp movie, you're not going to miss the Saturday movie, you're only going to miss the Friday movie, because you were never going to get to see the Saturday and Sunday movies. So this is a situation where future misbehavior lowers the cost of current misbehavior, so sophistication exacerbates the effect of short-run impatience. The naïf in the movie situation thinks that going to see the movie on Thursday is really going to hurt, because he thinks that it's going to make him miss the Johnny Depp movie. The sophisticate is correctly pessimistic about her ability to hold out for the Johnny Depp movie and realizes that actually the harm she causes herself by going on Thursday is only that she's going to miss the Friday movie. This principle is highly generalizable and you can take it to the bank.